The next problem deals with the numerical approximation Euler for systems, and the system was dx dt equal negative y, dy dt equal x. As you can see, this is a linear system, and you were given a solution which is cosine t sine t, okay, or cosine t minus sine t. Either you take the vector or the matrix representation of the solutions. It's very, very easy to check that indeed you do have a solution, because the derivative of x is equal the derivative of cosine t, which is minus sine t, which is the derivative, which is minus y. And the same when you take the derivative of y, which is the derivative of sine t, is equal to cosine t, which is equal to x. So this capital Y is indeed a solution to your system. Next, we wanted to use Euler. First of all, if you want to use Euler, before we do that, let me just explain that the graph, if you look at, it's very easy to see the graph of this solution in the phase plane, and the reason is because cosine squared plus sine squared is equal to 1. This is a parametric representation of this unit circle. So basically the graph of this is just the unit circle. Okay, and this is kind of ugly looking circle, but that's fine. So we start at this point, okay, that's y of 0, which is equal to 1, 0. Remember that cosine of 0 is 1, sine of 0 is 0. And it looks like we're going this way. And we stay on the circle. It goes around. It's a cycle, basically. It's a closed curve, okay? So this is the exact one. And now we go and we use Euler approximation for this exact solution. And to see, this is typical, you find the exact, and then you look to the Euler and see how far you are from the exact solution, because in general it's very hard to find the exact solutions. So here, remember that xn plus 1 is going to be xn plus delta t f of xn yn, and then yn plus 1 is equal to yn plus delta t g of xn yn. Okay, f of xy in this problem is equal to minus y, and g of xy is equal to x from the system. So the relationship between the point xn yn and xn plus 1 yn plus 1 is given by xn plus delta t time minus yn, and yn plus 1 is equal to yn plus delta t time xn. So again, if I put the stuff together, I will get xn plus 1 equal xn minus delta t time yn, and yn plus 1 is equal to yn plus delta t xn. Next, we need to find what is the initial point. So delta t is given to you as 0.5, and the initial point, y of 0, of the exact solution is given by 1, 0, sorry. 1, 0. So from here, we're able to find most of the points. So here you have, you can do any way, any representation as long as you find the xn and yns. So here you have, if you take t0 equal 0, then we know that y of 0 equal x0, y0 is equal to 1, 0. Next, we take t1, which is t0 plus delta t, and that's 0.5. So we need to find x1, y1. So x1 is equal to x0 minus 0.5 times y0, and y1 equal y0 plus 0.5 x0. So if you put this stuff together, you will find that this is equal to 1 and this one is equal to 0.5. So then you go for T2, which is T1 plus delta T, and that's 0.5 plus 0.5, that's 1. And we look for x2 and y2, and etc., etc. So if you take T3 is going to be 1.5, T4 is going to be 2, T5 2.5, T6 equal 3. And the question was, what happened at T4? T equal 4, so we need to go all the way to 3.5, T7 3.5, T8 equal 4, and that will give you x8, y8. And then you continue again, T9 4.5, T10 equal 5, T11 5.5, T12, and that's 6, and that will give us x12, y12. So I'm going to give you the detail of how to find these points, but let me give you just the answer. For t equal 4, okay, which corresponds to T8, n equal 8, that will be x8 equal x8 will be equal to minus 2.05, y8 will be equal to minus 1.31. Okay, and for t equals 6, which is x12 and y12, we will find 2.86 and minus 2.51. Okay, so as you can see here, in both cases something is totally wrong, because the exact solution is on the unit circle. Therefore it's a cosine and a sine. So as you can see, minus 2 is bigger, minus 1.3. They're all the numbers, 2.86 minus 2.51, are very far from the unit circle. These points are getting, of course, t equals 6 is getting farther and farther from the unit circle than t equals 4. We're still not far, but not that far compared to t equals 6. So if you draw the solutions, if we go back, because we already drew the solution. So here, so this graph is too small, so let's go back. I'm sorry. So let's here, and this is the unit circle. And if you start at this point, if we take now the red approximations being the red one, you will see that your points are like this. So as you can see, the solution is getting very, very far from the exact solution. So the approximation is going around, it's spiraling, that's getting farther away from solution. We can even compute the error between the exact point, which is the distance from the point y6, the exact solution, and the point x12, y12, which is equal to the square root of x12 minus cosine of 6 squared plus y12 minus sine of 6 squared, which gives the value of 4.655. So the error is quite big compared even to the size of the points.